In this video, we're going to discuss features of inheritance in Java programming language. The main question, what is inheritance and why we need it? And there is no simple answer. There are many answers to this question because inheritance is a combination of different features, rules, and behaviors. It's a concept that we will approach one thing at a time. You already know that Java program has objects in memory. So these objects interact with each other by calling each other's methods. That's the core of a Java program structure, objects in memory. Soon we discover that objects often have many things in common with each other. Some data attributes are the same, some methods may also be the same in different objects. Consider an employee class. An employee can be a manager, a full-time, a part-time, or a consultant. And these kinds of objects are different and have specific things in them. But many data attributes are the same between all employees, like employee name, social security, or home address, and so on. Those are the same for a full-time or part-time employee. So we need to be aware of those observations. In fact, we must keep track of common parts of our objects to make sure that we implement a correct design of our software. Java inheritance, also known as class hierarchy, can facilitate proper memory management of our objects and help us organize consistent behavior of objects which can interact with the system in convenient and well-maintainable manner. So inheritance allows to address these kinds of issues, maintainability of our software and correct memory management. So let's begin with an example. I already created an empty project right here with the main class for today's demonstration. So we can get started. So let's consider a concept of an employee. I will go ahead and create a class named employee, just like this, and add it to our package. So for now, just get rid of Java docs, and this is our class employee. So first, let's talk about some data attributes. Right, so what could be these data attributes? We can just start with a string name and also a string tax ID, right, like social security number. So that's just an example of an employee with this information. We may also consider, for the purposes of pay computation, we can have like public static final, which makes it constant, week hours. So we can add this constant to our system, and we can say that, for instance, 8, which would be hours, multiplied by 5, which stands for weekdays, something like this. Right, so this would be a constant, which is like 8 multiplied by 5. So this will be 40, but I'm trying to explain what this is, and I forgot to give it a type, so this will be an integer. Right, so this is fine. All right, so what's next? We also would like, of course, to have a constructor. So I'll just, at the top, I'll just say these are constants. So these are helpful constants. Do I spell it correctly? Okay, and then we will have some constructors. I'll just say public employee. Of course, it'll require these two strings, string name, string tax ID, and pretty standard way of initialization. Basically take both of these, this name equals name, and this tax ID equals tax ID. Alright, so we just have a constructor that populates both of these quite nicely. So then we can add a method. Of course, we can have setters and getters for the name and tax ID. We can add those later. But in terms of methods, let's say operations that are available will be public and could return a double. And we can say compute pay, and it'll take, let's see, we could have something like payroll object, payroll. Okay, I'll talk about this in a second, and also double, or rather integer, I think integer, hours worked. Right, so something like this. And we'll compute this as, we can just simply return from here, return these, let's say, a weekly salary, right? So we can have, we probably need this is a regular employee, like a full-time employee, so add this double weekly salary. Okay, so probably need this also to initialize our object right here, weekly salary. So we can then take this weekly salary and multiply it by something like hours worked. Right, so we get the hours that the employee worked and divide them by week hours. So because our salary is specified as weekly salary, we need to compute how many weeks these hours worked correspond to. And so that's the formula, right? So we take the salary, multiply by the amount of weeks. Okay, and we can actually clarify it by declaring a variable right at the top, integer weeks worked, right? So how many weeks equals this, right? And then we take weekly salary, multiply by weeks worked, just to keep everything readable and you know, explained, self-explained by the formula and the names of the variables. And to keep it more realistic, I would like to add a payroll. I think we need to spell it with double L right here. Right, so I would like to add the payroll class to the system, just to keep everything realistic. And this will be a class with a set of methods to run the payroll in our system. Okay, so we go to our package and also create new class, and we'll call it payroll. Okay, so we'll create this, and so one of the, in fact, let's talk about the responsibilities of this payroll and the reason why we have it here. So the object here is responsible for printing checks and generating direct deposits to employee accounts. So payroll is also has the responsibility of keeping the total amount that is payable to the people employed by the company. So once the payroll is executed, we know how much total we have to pay. So let's say this will be our private double payroll total. Okay, so we can have it initialized to 0.0. Okay, so we just start with 0 and we'll accumulate payroll as we run our computations. So for this reason, we really don't need a sophisticated constructor, right? So these are pretty much all the data attributes that we need here. In fact, let's keep this side by side so we can see both of our classes at the same time. All right, so here we'll add operations, and I'm thinking of operations such as once we instantiate the object, we can run the payroll. Right, so we can say this is public. For now, we can say void run payroll. And this run payroll method will take an array list of employees, right? So we'll construct the array list of employees, and we'll call them employees right here. This is a collection of employees that we will give to this method run payroll. And here we'll do something like, of course, here we can press Alt Enter and say import Java util array list to keep everything good. And here for now, just something like for each employee in this list of employees that we've given to this method. I'm expecting that our main main method will be calling this run payroll for the list of employees. We're going, for each employee, we're going to call compute pay, right? And it's so compute pay and hours worked. We need to come up with something. Let's just hard-code it for now. Let's say 1 week hours, right? Yeah, we already have this constant, so we can just pass this as a standard way of doing it. So we can say employee week hours. Okay, so that's what I'm going to do to just keep everything simple. Now notice that when we run this payroll and we just do this standard hours for 1 week, and we pass the reference to the payroll object itself to compute pay for each employee that we try to compute this payroll for. And we pass this payroll to this object. So we'll create both an instance of payroll in the main method, right? So here we'll just say payroll equals new payroll, just a simple way of making sure that we have it. And then we'll populate collection of employees. But I just want to make it pretty clear that here we're creating an object of this type, right? So we have this new operator, which of course will create an object of this type. So we'll have a reference of an object that's of this type, named payroll. So then when we so let's then create an array list, and this will be an array list of employees. So this will be the same name, and then equals new array list. And we'll populate this later on. And of course, again, you can press Alt Enter and choose to import Java array list. And here, just for the sake of demonstration quickly, we're going to go to, say, Payroll, run Payroll, and we'll pass the list of employees right here. Okay, so first we will populate the list. Okay, so we'll do it later, but right now just an idea of saying run this payroll. So once again, when we create this object, right, so when we create this object named payroll, so now this object is in memory, I draw them as boxes, and so this is the reference to this object. Then we make a call into run payroll. So now this method, of course, this method right here belongs to this object. It's an instance level method, and what it needs to do, it wants to make a call into compute pay, and so somewhere we have employee objects, right? So this is an employee. This is payroll right here, and this is an employee, and this is reference to the employee. And then we make a call into compute pay, right? And inside this compute pay, we want to provide this method with access back to the payroll. So this reference is also pointing to our instance of the payroll. So outside of our object, we give it a name. We say payroll. But then we call run payroll, which belongs to this object. So inside this object, we still have access to the memory location of our payroll object by keyword this. So every instance method like this run payroll, has a reference to the object. So now this reference will be passed to our employee compute pay right here, and this payroll once again is pointing to the same object that I was showing you earlier, right? So this is a reference to it as well, and there inside the main method we also created this payroll. So from main we also had a reference to the same object. So this keyword is quite helpful when you need to pass a reference to this object to some place outside of the scope of this class payroll. Every time we have a method, we can pass this reference over to another place in our program.